that is, we need to find the Fourier transform of f of x is equal to a square minus x square when mod x is less than or equal to minus a, or else we can write it as x, the value of x lies between minus a to a, or the value of f of x is given as 0 when mod x is strictly greater than a, where a is a positive constant, that is a is greater than 0. So now we know that the f of s, in order to find the Fourier transform, this is the general form. So now the limits would be from minus a to a, right? I've just splitted the limits. Since the minus infinity to minus a, there is no value given for f of x, so that limit interval is neglected, and the interval from a to infinity, the value is 0. Only this interval remains, that is from minus a to a, and here the f of x value is given as a square minus x square e power isx into dx. Okay, so now we need to solve this further. That is, now we are going to use the Bernoulli's rule to solve. Okay, first function and second function. So first function, keep it as it is into the integral of second function, that is e power isx divided by the coefficient is is minus of differentiation of this function, that is a is constant, so it is 0, and differentiation of x square is minus 2x into the integral of the integrated function, that is e power isx divided by, this becomes now I square s square, plus the differentiation of minus 2x is minus 2 into the integration is e power isx divided by I cube s cube. Limits are from minus a to a. So now let's substitute the limits. This becomes a square minus x square, the limit is a, so a square into e power is a divided by is. In place of x I am writing it as a, plus minus into minus is plus 2a into e power isa divided by I square s square minus, this is minus, right, 2 into e power isa divided by I cube s cube. Okay, so now minus the lower limit, that is a square minus minus a the whole square, that is again is equal to plus a square. So this is a square minus a square into e power minus isa, since the limit is, lower limit is minus a, divided by is minus 2a into e power minus isa divided by I square s square minus 2 into e power minus isa divided by I cube s cube. Okay, so now f of s is equal to 2a into e power isa divided by I square s square. Since we can see that a square minus a square is 0, right, so this term whole becomes 0, and here also a square minus a square is 0, so these two terms gets cancelled. I am writing the remaining terms now, minus 2 e power isa divided by I cube s cube. So minus into minus is plus 2a into e power minus isa divided by I square s square, minus into minus is again plus 2 e power minus isa divided by I cube s cube. Now here in the denominators we can see that we have I square and I cube, right? So here wherever there is I cube s cube, split it and write it as I into I square, so that we can I into I square, so that we can substitute the value of I square directly as minus 1, right? So I am going to write it now. So this becomes minus 2a into e power isa divided by s square. How this becomes minus? Because I have substituted the value of I square as minus 1. So this, wherever this plus is there, right, so this becomes minus now. Similarly goes for the second term. So now here there is minus, right, so the signs will interchange and it becomes plus 2 into e power isa divided by I s cube. Since I have splitted I cube by I into I square, and the value of I square is -1, so the sign changes from minus to plus and only I remains. So similarly here also sign changes, 2a into e power minus isa divided by s square minus 2 into e power minus isa divided by is cube. F of s is equal to, so in these two terms we can observe that these two terms we can take 2a by s square common outside. We can take minus 2a by s square common out, and the remaining terms are e power isa plus e power minus isa, right? Plus in these two terms we can take 2 by is cube common outside, and the remaining terms are e power isa minus e power minus isa. So here again we can observe that this is of the form of sine and theta function. So we can write this as, so there is plus, right? If there is plus, we can say that it is a cos function, right? And if there is plus along with the imaginary term, it is divided by 2, and if there is minus, we can say that it is a sine function, and in sine function we know that it is divided by 2i. So here in this case we are going to multiply and divide by 2, and in this case we are going to multiply and divide by 2i. Okay, so this is, if we multiply and divide by 2, the numerator will be 2 cos theta. In place of theta, now the value here is, in place of theta it is a into s, right, plus 2 by is cube. So here we are multiplying and divided by 2i, right, since there is minus, so 2i sine a into s. So here we can cancel this I, so the remaining terms are 2 into 2 is 4 minus 4a cos as by s square plus 2 into 2 is again 4 sine as by s cube. This is your required final answer for this solution. We need to find the Fourier sine and cosine transforms of the function f of x, which is given as e to the power minus alpha x, where alpha is strictly greater than 0. That is, we can say that alpha is a positive constant. So first we are going to solve it for Fourier cosine transform. I am given it as FCT, short form. So the Fourier cosine transform formula, as we have discussed, is fc of f of x is equal to, interval is from 0 to infinity now, f of x, since it's a cosine transform, the function is cos sx into the parameter here is dx. Okay, so now in this we are going to substitute the value of f of x, that is fc of f of x is equal to 0 to infinity, the value of f of x here is e to the power minus alpha x cos sx into dx. So if we see this function integral very carefully, this is of the form e to the power ax cos of bx plus c, right? This function is equal to e to the power ax divided by a square plus b square into a cos bx plus c plus b sin bx plus c, right? This is defined like this. So in the same way, in place of here a we have alpha, and in place of b we have s, and the value of c here is 0 since it is not given. So in the same way we are going to substitute this, and we are going to write it in the form of the given integral. Now fc of f of x is equal to e to the power minus alpha, here the value of a is minus alpha x divided by a square, that is minus alpha the whole square. Minus alpha the whole square is equal to alpha square only, right? Minus alpha into minus alpha is equal to alpha. So it is given as alpha square plus the value of b here is s square into minus alpha cos sx, that is a cos bx, plus b is equal to s cos sx, s sin sx, yeah, and the interval is from 0 to infinity. Okay, so now here we can take 1 by alpha square plus s square common, and we can multiply e to the power minus alpha x to both the terms, that is e to the power minus alpha x into, here is a minus sign, cos sx plus e to the power s into e to the power minus alpha x sin sx, and the limits are from 0 to infinity. So now we are going to apply the limits, that is 1 by alpha square plus s square is constant, it remains outside. Now the limits are from infinity, so e minus e to the power minus infinity, right? So alpha, now we are in place of x we are going to write it as infinity. Infinity into anything is infinity only, into so here there is an alpha term, okay, into minus alpha. So yeah, let's make this plus and let's take minus alpha common. So here I just made the change, that is this e to the power minus alpha x is there, right? I have taken common in these two terms, okay, so that we can split the limits only for these two functions. Minus alpha cos of infinity plus s sin of infinity minus e to the power alpha x, so in place of x now the lower limit is 0, minus alpha cos 0 plus s sin 0. Okay, so we know that e to the power minus infinity is equal to 0, right? So this whole term is 0, and the value of sin 0 is also 0, so the remaining terms here are 1 by alpha square plus s square into e to the power 0 here is 1, so minus into minus is plus, so 1 into alpha cos 0, so cos 0 is again 1, so 1 into alpha, so the remaining terms are alpha divided by alpha square plus s square. So this is your required answer. This is for Fourier cosine transform. Okay, so now we are going to find the Fourier sine transform. Yeah, so this is the formula for Fourier sine transform. So here in place of cos we are just replacing the parameter of sine, the rest all the things remains the same. Okay, so now let's substitute the value of f of x, that is 0 to infinity e power minus alpha x sin sx into dx. Okay, so here again we have the formula for e to the power ax sin bx plus c, right? That is equal to e to the power ax divided by a square plus b square into a sin bx plus c minus b cos bx plus c. So now we are going to replace these values. Yeah, so now we are going to write it as a sin bx, right? So minus alpha sin sx minus b cos bx, so s cos sx from 0 to infinity. Here the value of c is 0, so we are not writing it. So now again in this case we are going to take 1 by alpha square plus s square outside, and e power minus alpha x as common for both these terms, so it will be minus alpha sin sx minus s cos sx, and the limits are from 0 to infinity. So now let's apply the limits. e to the power, the upper limit is infinity, so it is e to the power minus infinity, x is replaced by infinity, and infinity into anything is again infinity only, into the brackets minus alpha sine infinity minus s cos infinity minus e to the power, again x is replaced by 0, lower limit, again it is e to the power 0 minus alpha sine 0 plus s cos 0. So here e to the power minus infinity is 0, so this whole term is 0 and sine 0 is 0. So the remaining terms here are 1 by alpha square plus s square, minus into minus is plus, and e power 0 is 1, and s into cos 0, here cos 0 is also 1, so the remaining term is s. So the final answer which we get is s by alpha square plus s square. See, there is no much difference in the answer which we have got here and here. Here in case of Fourier cosine transform, here in the numerator we have alpha, and in sine transform in the numerator we have s. Okay, I have told you, right? Here they won't be giving any f of x or f of s values. After that, for that we need to find the Fourier transform, again inverse transform. No, for that, in this kind of problem they would be giving the integrals itself. First thing what we need to do in these kind of problems is we need to identify whether it is a Fourier sine transform or cosine transform, and for this integral they would be giving some certain values, and we need to be knowing where to use these values. Okay, so the first question given here is we need to solve for the integral 0 to infinity f of theta cos alpha theta into d theta, and it is given as it is 1 minus alpha when alpha value lies between 0 to 1, and it is 0 when alpha is strictly greater than 1. Okay, and here also we need to evaluate these two cases, that is 0 to infinity 1 minus cos x by x square into dx, and the other case is 0 to infinity sine square t by t square into dt. Okay, so first thing we need to identify this equation. By seeing this equation we can see that the interval is from 0 to infinity, and here the function we have is cos. So here we can guess that in this integral is an Fourier cosine transform, right, since we have cos. But the formula for Fourier cosine transform is f of x cos sx into dx, right, 0 to infinity. Here what are the changes we observe between this equation and this equation? If you observe carefully, in place of theta, in place of x we have theta, and in place of s here we have alpha, right? So the same thing we are going to write it as solution itself. Here first write that by comparing these here we can see that the first thing that we need to know that this is an Fourier cosine transform, right? By comparing these two equations here, write the values which are equal, that is here the x equal to theta and s is equal to alpha. So now first thing we need to do is we need to use the inverse Fourier cosine transform. Since this integral is of the form Fourier cosine transform, the first step we need to use is we need to use the inverse Fourier cosine transform, that is fc inverse of fc of theta, right? Here in place of s, fc of theta, and it is given as 2 by pi into 0 to infinity f of theta, right? So it is not fc of s, it is fc of theta now, f of theta into cos alpha theta, and the parameter is from d alpha because the value of s is equal to alpha, right? So here instead, generally we had for inverse Fourier cosine transform it as ds, right? So here the parameter s is equal to alpha, so we need to write it as d alpha. Okay, and that is again equal to f of theta. It is not equal to f of x because in place of x we have theta here, right? Okay, so now write it as f of theta is equal to 2 by pi, and here the limits are from 0 to 1 and 1 to infinity. We are not going to write that 1 to infinity. I am just splitting the interval, that is from 0 to infinity. So 1 is from 0 to 1. Here it's given as 1 minus alpha, and it is 0 when 1 alpha is greater than 1, so I am not writing that. So here the value of f of theta given here is 1 minus alpha in the question, cos alpha theta, and the parameter is d alpha. Okay, so now for this we are going to use the solve this integral now. Okay, 2 by pi into the, we are going to use the Bernoulli's rule now. Okay, so first function as it is, here we need to be very careful by solving the problem, since the parameter here is not dx, right, it is d alpha. In such a way we are going to solve this now. Okay, into the second function, that is cos alpha theta. The derivation of cos is sin alpha theta divided by, now the parameter is not the parameter is d alpha, right? So now we need to see the coefficient of alpha, not theta. Okay, in order to write the denominator, the coefficient of alpha is theta right here, so we are going to write it as sin alpha theta by theta. Okay, minus the differentiation remains the same again. Differentiation of 1 is 0, and alpha here it is not a constant term, so we need to consider it as a variable. Okay, so the differentiation of any variable is minus alpha is minus 1, into again the integration of this function, minus cos alpha theta divided by, since the parameter is alpha, we need to take the coefficient of alpha, that is theta, into the integral is from 0 to 1. Now apply the limits, that is 1 minus alpha, right? So the parameter again is alpha, so wherever there is alpha in this equation, substitute the limits there only. Okay, so 1 minus alpha, replace alpha by the upper limit 1, so it is 1 minus 1 into sin alpha is 1, right, so it is sin theta by theta, minus into minus, plus into minus, minus again cos theta by theta square, right, minus the lower limit, that is 1 minus 0, 1 minus alpha is 0, 1 minus 0 is 1, so sin 1 into sin 0, right, alpha is 0, so 0 into anything is 0, divided by theta, minus cos 0, again minus into minus, plus into minus, minus by theta square. So now by solving we get it as 2 by pi into, so 1 minus 1 is 0, so this whole term is 0, sin 0 is 0 again, so the remaining terms are minus cos theta by theta square, minus into minus is plus cos 0 by theta square. So now f of theta is equal to, we can take 1 by theta square common outside. Okay, so this would be 2 by pi theta square into cos 0, let's write the positive term first, cos 0 is 1, right, minus the remaining term here is cos theta. So this is your required f of theta. So now first, in this case we have used first the inverse Fourier cosine transform, right? So now we are going to apply the Fourier cosine transform, that is the given question. In the given question this is given, right, this condition. Here it is given that f of theta into cos alpha theta d theta. Here f of theta is there, that is we have found the f of theta using the inverse Fourier cosine transform, right, this f of theta. The same thing we need to do here, that is we need to replace the value of f of theta in this equation and solve the rest of the problem. Okay, that's simple. Now let's solve it. That is fc of alpha. Generally we would be having fc of s, right, but we know that here s is equal to alpha, parameter s is equal to alpha, so it is fc of alpha into is equal to 0 to infinity f of theta. The question itself we are going to write it again, cos alpha theta d theta is equal to, it is 1 minus alpha when alpha and 0 when alpha is greater than 1. Okay, so now substitute the value of f of theta which we have solved here, that is 2 by pi theta square into 1 minus cos theta into cos alpha theta d theta. Okay, so now the first thing we need to evaluate here is 1 minus cos x by s square. Yeah, I forgot to tell you that we are doing applying this Fourier cosine transform to evaluate. Okay, first thing we have found the f of theta, right? So we are applying this applying the Fourier cosine transform and substituting here f of theta because we need to evaluate the cases. Okay, for that we are doing this. So the first thing, evaluation case is 1 minus cos x by x square, right? So here we have 1 minus cos theta and here we have theta square. The rest of the terms, right, that is 2 by pi and cos alpha theta, that terms are now in our path, that is we need to separate them. So the first thing we can do here is we can take this 2 by pi common outside, infinity 1 minus cos theta by theta square cos alpha theta d theta is equal to the same thing, that is this condition itself. So now in the next step what we are going to do is we need to put the value of alpha is equal to 0 so that we eliminate this term, because we need only this term, right, like this 1 minus cos into something divided by something square, right? We have theta here. If we are at last step we need to replace the value of theta by x, right? So we don't need this. In order to eliminate this, put the value of alpha is equal to 0, so this gets eliminated. Okay, yeah. So if we put the value of alpha is equal to 0 in this equation, 1 minus alpha is there, right? So in this side it is 1 minus alpha. It is the integral is from 0 to infinity, and we know that it is splitted from 0 to 1 and 1 to infinity, and from 1 to infinity the value is 0, so we are not going to write the second case now, 1 minus alpha. So now when we put the value of alpha is equal to 0, so now this would be 1 minus 0, right? So now let's write the remaining equation, that is 2 by pi 0 to infinity, put alpha is equal to 0 here. Okay, 1 minus cos theta by theta square into d theta. Cos alpha theta would be eliminated, right? That is equal to 1 minus alpha, right? So 1 minus alpha means 1 minus 0, therefore 2 by pi 0 to infinity 1 minus cos theta by theta square d theta is equal to 1. So now bring this 2 by pi to other side, that is 0 to infinity 1 minus cos theta by theta square d theta is equal to, there is 1, right? So if we bring this to other side it would be pi by 2. So now again we have nearly completed the problem. Here now we need to replace the value of theta by x. Okay, so that we will get our first case, that is 1 minus cos, wherever theta is there replace it by x square dx is equal to pi by 2. See, we have evaluated one case. So now the one more is there, that is sin square t by t square dt, right? Yeah, so now we'll do that. So now we need to find the second case, that is sin square t by t square into dt. Okay, so now here in order to find this, right, we need to use the above equation, that is the above first case that we have solved. By using that equation, let's name that equation as 1. So using this above equation 1, we need to solve for the second case, that is, what is the first equation? 0 to infinity 1 minus cos x by x square dx is equal to pi by 2. So we have an identity for 1 minus cos x, right? Yeah, the 1 minus cos x can be written as 2 sin square x by 2, right? Okay, so now we are going to write that itself. So I'll write it here, since 1 minus cos x is equal to 2 sin square x by 2. Okay, so now in this equation, so now equation 1 would be looking like 0 to infinity 1 minus cos x is replaced by 2 sin square x by 2 divided by x square dx is equal to pi by 2, right? So now again the same thing here, x by 2, take x by 2 is equal to t. Okay, so now bring this 2 to other side, so x is equal to 2t differentiate on both sides, therefore dx is equal to 2 dt, right? So now replace these values in this equation. So that is 0 to infinity 2 sine square x by 2 is equal to t divided by x square. So x value is 2t, so it is 2t the whole square, and dx is equal to 2 dt, right? That is equal to pi by 2. So this is 0 to infinity, 2 into 2 is 4 sine square t divided by 4t square dt is equal to pi by 2. So now if we cancel this 4 and 4, so we left the terms left out are sine square t by t square into dt is equal to pi by 2. So that's all we need to solve, right? We need to solve this only, right? So now see, by using the first equation we have solved this case also, right? So in this case in this way we need to solve these particular integrals when they have given the integral. So